Okay, hello, this is the third video of chapter 1. So far, we have defined probability, and it's a way of summarizing the data, and I showed you how to calculate the probability, which was pretty easy, too easy for most of you. So, um, in this video, I'm going to show you a real data that is more complicated, and we'll study how we can apply the same structure to the real data. So typically the main problem is when you have multiple variables, then the problem gets a little more complicated, but the idea is the same. So here I'm going to show you the NLSY data, which stands for National Longitudinal Study of Youth, and it started from 1997. So I have the actual data. So I'll show you like this. I'm going to post this Excel file with the slide, so you can play with the data by yourself. And here, let me show you, there are information about gender. So think about this. It's a survey. So what we do here is randomly choose a person and ask about his or her gender and the birth year and race and region of residence and education, marital status, employment status, and health insurance coverage status, right? So we asked 1, 2, 3, 4, 5, 6, 7, 8 questions after choosing a random person, right? So in this way, to see what to see how many data we have, if you if you press Control and arrow down, then you can see the number of observations. We have 7,154 observations. I subtracted 1 because the first row is just label. So there are more than 7,000 observations, which is large, but actually in practice, in real state-of-art research, this data set is not that large. Big data or huge data means several millions and more than that. So like 7,000 is pretty cute data. And now, then this is a big problem. Like, you have too many observations, too many information in here. I wanted to show you what is going on, but giving you this file does not help that much. It does not summarize any information, and you cannot understand what's going on. So on Excel, it's one thing I'll teach you is doing this filter. So in case if you don't know, if you have not used Excel before, or if you didn't know this yet, this is the most useful, one of the most useful tools on Excel. So when you put filter, choose the data area and choose filter option, press this, click this, then you can see it's out of monitor. So if you choose this drop down button, then you can see the options. So under the marital status variable, there are 5 different outcomes: divorced, married, never married, separated, widowed, right? And similarly, like employment status can be employed, not in labor force, or unemployed. In this way, you can have a better idea what's going on in the data. So under the education variable, ungraded, there is some ungraded, and other than that, from 5th grade to 12th grade. So you can see what happens. Like, race is classified as black, Hispanic, mixed, non-black, non-Hispanic, like this. So you can see what are the sample space for each variable, right? So the birth year, I have to move it a little like this. The birth year ranges from 1980 through 1984. So the sample space of the data, this variable, is 5 years. those who were born in these 5 years, right? And of course, gender is male or female. And region is divided into 4 parts. And health insurance coverage is yes or no. So using the filtering option, you can easily check the sample space. What are the possible outcomes? Or in other words, what were the options, answering options in this questionnaire of this survey, right? So that's an easy way to check the data. Anyhow, go back here. That is the data, example data we can think of. So just to describe a little bit, it is collected every year from 1997. So it is called longitudinal data. That means, so in 1997, I choose random young people and ask them about their, birth year and like these information. And then I, like the survey research center that conducted the survey, contact them again every year. They survey the same group of people every year since then. So this structure is called longitudinal data. So a person is observed several times over time. And what I just showed you, the data in this Excel file is 2006 survey. So it's 9 years after the original, the initial survey, and so there is actually 8 more surveys before what you observe, and there are also more surveys after this observations. But I'm just choosing 1 year, which we call cross-sectional data. So the original structure was longitudinal, like it's over time for many people, but I just use a cross-section at 2006. So that's what I do. So the population is those who were born between 1980 to 1984. So maybe those who were born the United States, maybe citizens who were born in 1980 and 1984. But as you know, we cannot meet all of them. Ideally, if possible, I hope to ask every person that satisfies this condition. That is the population, but that is not possible. Realistically, that's not possible. So we only observe 7,100 of them, which is just part of the population, right? So there are some problems, like I asked question, but they may not answer, or they may skip some questions. So after removing those kind of missing values, the final observations is composed of 7,100 people. Then, now you can understand how these data are generated. It is a sample generated this way. The underlying experiment is to randomly choose one person who satisfies this condition, right? So this randomness, random choice is the key. And then after you choose a person, then you ask 8 questions: gender, birth year, region, education, like marital status, employment status, blah, blah, blah. Those 8 questions are asked. And then when you get one answer, you have 8 observations. Choosing one person is one experiment, and then you ask 8 questions. So one person generates 8 cells, 8 observations, 8 entries. So in this case, you have to understand that still it is one experiment. One experiment, randomness is coming from one person, choosing one person. So even if you observe 8 observations, still it counts as one experiment. Sample size is 1 if you choose only one person. So in our data set, we have 7,154 people randomly chosen. So the sample size is this, sample size is 7,154, but actually in Excel the entries are 8 times more than that, because for each person there are 8 entries. However, the number of variables does not count as repetition. So the point is repetition of experiment, and even if you ask 100 questions, that does not change the number of repetitions, right? Just one repetition generates more than one outcomes. More than one, I mean more than one entries in your file, in your sample. So you can understand it this way. One experiment is one person, choosing one person. So in Excel file, it is one row. One experiment equals to one row. And because we had 7,100 rows, so we can say that there are 7,100, the experiment was repeated for 7,100 times. That is the sample size. On the other hand, a column is just one variable. Like it's just up to your interest. So if you're interested in gender, then this is your variable. But number of variables does not matter in your analysis. Of course, having more variables will help because you have more information. But it's there is no direct effect on the accuracy of your statistical analysis. So it depends on your topic. Okay. So then, what I want to do next step, the next step is to summarize the data. Right? So far we looked at the structure of the data, but now I'm going to show you how to make a probability distribution table like this. Okay, so go back to our data. So like what I'm going to do is I'll first show you how to handle health insurance variable. So there are a variable named health insurance coverage, and there are yes or no in its sample space, and I would like to count how many of them answered yes and how many no. That is not easy, of course. Like maybe you can choose like this. So in here, you may turn off yes, and then you only have no people, but still it is not easy to count how many, right? So I'll show you an easy way to do that, which is called pivot table. So go to insert tab, then there is pivot table. So I will click this area and click this, then you are going to see some option, and I'll just click OK. Then there is something on here you have to choose from this. Click this variable. This is the variable we are interested in. If you click here, then according to this variable, the sample space is shown here. Blank is included, but you can turn it off. We are not interested in blank. It's up to you. We know that there is no blank, so we don't need to worry about that. And what you need to do is you have to fill the content of the table. We are going to drag this to values. So if you drag this variable to this panel, what you see is the count. The default is count. So you learned that there are 2,410 people who said no in our sample, and more than 4,700 people said yes. And their sum, grand total, is the sample size again. So this is the frequency distribution table, right? So remember, this is pivot table, and you have to enter this variable into values. Then let me change this. How can we change this to probability? Like I will show you another thing. If you drop this and bring it here again, then another column is generated. pivot table is like this. So same thing appears again, but I'm going to change the second one. By click here, and choose value field settings. And then you may change your options, and especially I'm going to click the second tab, show values as percentage of grand total. So far there was simply no calculation option. It was no calculation, but now I'm going to choose percentage of grand total and click OK. Then you see percentages. This is how you change data into frequency or probability. So I hope this is more useful. So this is more important and useful tools in your life than memorizing statistical formulas. So Excel skills are really important, or you can expect that in your career. So I hope this helps. And back here, this is the number we obtained from the pivot table. So then I will ask you a question. So you can do the same thing with two variables. Let me redo that again. So back to the original data. Last time I selected only this column and clicked pivot table here. But now I'm going to choose, let's see what happens if you click everything, select everything, and click pivot table. Then the range is all data, not just one variable. I click OK. Then a new sheet is made, and here you see all the variables. Now it is up to you. I will, in the slide, I am interested in gender and health insurance coverage. So I will use these two variables. But when I click these two variables, the problem is those two variables are added in the same panel, in the rows panel. So they are shown like this. But I'm going to move one of them to columns panel. Then you have rows are defined by health insurance, no insurance, yes insurance, blank, and female, male, blank. And this is what we want. So columns are defined by gender, and rows are defined by health insurance status. Now what we are going to do is you can drag, like you have to fill the values panel. You can just drag actually anything. If you drag a health insurance variable, you have the same thing, or you may drag gender. You have the same thing. It doesn't matter because it is just counting. It doesn't matter what is the observation. So either way, it results in the same thing. You can drag actually any variable, like race will give you the same thing. And as I did before, I'm going to change the value settings, value field settings, and shown value as percentage of grand total. Then you will get percentage. So let's turn off blanks, because we don't have blank. Then this is a nice 2x2 table. 2x2 table on these two variables, right? So you can do this for any variable you want. Of course, the table may be more complicated if you use another variable. For example, now let's just try different things. Race and region. Let's see, and I'll bring region here, and I will bring one here. Then it becomes 4x4 table because each variable has 4 possible outcomes. Race has 4 possible groups, and region has 4 possible regions. So, as you see, the resulting table depends on the variable you choose, and you can do the same thing as usual, like And then you have 4x4 probability distribution table. This is how you make probability distribution table in with two variables, and this is what we obtained for these two variables. And finally, like short question, I will finish this video with this question. How many outcomes in the sample space in this table, given this probability distribution, how many possible outcomes, do you think are in the sample space? I'm going to continue in the next video. See you later.